Okay.
So, hello everybody. Welcome to another NetBrain seminar. And today's speaker is Hygor Melo. He's going to talk about evaluating urban accessibility, and also he's going to share some experience in surviving as a frog in a world of birds. So, Hygor, whenever you want.
So let me just control here the time. Okay, I can. So thanks. Thank you, guys. I also want to say something to Gabriele. I want to thank the invitation. Unfortunately, he is not here, but I share this with all you guys. I think it's a very nice initiative. And not only discussing science, but also this second discussion that you guys do is very interesting because I think on myself, I mean, maybe I don't look that old, but I'm sure that I am much older than all you guys. And I would love to have something similar to this when I was doing my PhD. And I think would be great. I think would help me on some decisions that I take, some stupid decisions that I took. Probably I would have thought differently if I had something like that. So I think it's a very nice what you guys are doing. Okay, so having that said, so I will go with this first talk. And so if I'm speaking too much, you guys can tell me. I don't know. I think I have 30 minutes more or less, no? And you guys can tell me if I'm speaking a lot, and then I can cut something. So my name is Hygor. I'm associate researcher at Sony CSL. I don't think I need to introduce the lab because I guess if you are following the seminars, you probably saw the seminar of Matteo Bruno a couple of months ago, actually last year, I think. And I think he introduced our lab, but we can discuss later if you guys want. And I will move directly to the topic of my talk. And actually, before moving directly to the problem, I like to start with this provocative question that I think is what drives our small group of me, Matteo, and all the students and researchers that are with us here. That is what makes a good city. So I don't think we have an answer for this question of what is a good city. And I don't know if actually anyone has it, but there is some research on this line, and I think one of the biggest voices on try to answer this question is actually, it came from the work of a journalist called Jane Jacobs on this book, The Death and Life of Great American Cities. And I guess Matteo also mentioned this on his talk. If not, it was very bad. He should. So if you, in case you don't know this book, I really recommend you to have a look on it. And she proposed 4 conditions to promote life in a city. She says that you need to have high density, small blocks, diversity of buildings, mixed land use with different activity time. I like to show 2 examples to represent perhaps the 2 extremes on some of these conditions. So this is Pacaembu, São Paulo. So I'm from Brazil. I actually grew up in São Paulo. So this is not. This is so I guess you guys all know São Paulo is a huge city. It's about, I think, 15 million people living there, and it's a very problematic and difficult city to live in. And one of the biggest problems is that it is the opposite, and in some aspects, it's the opposite what Jane Jacobs described as a good city. So here's an example of a neighborhood called Pacaembu. So it's a high-income neighborhood. It's near the center, more or less, have somehow good accessibility to public infrastructure regarding mobility. I think they are now opening a metro line that will go through this neighborhood. Still, you have very low density. If you see in the picture, most of the neighborhood is covered by mansions, by big houses with pools. So the density is very low. So what you have in São Paulo is a perversion. You have the opposite what typically you have in Europe with the city center with high density in the periphery with low density. In São Paulo, what you have is the city center with very low density, usually with some people who live there have some privilege, and they have access to the public infrastructure, while people who live in the periphery in neighborhoods with very, very high density, all the public infrastructure, it's lacking. And you can see the transition, no? You see that the neighborhood, you see that all these houses, and then you have this neighborhood on the north side where you have the totally change on the type of housing. Also, you have high rises and so on. So in the opposite, an opposite example is this district in Tokyo, where I like to, where you can see what is maybe the definition of very, very high density. So you have this series of restaurants with just a couple of meters long, and so people can enjoy to have access to different options in just a couple of meters. Still, to study this, it's very complicated because it's very hard to find a single observable to measure that can be used to understand all these aspects in the city, no? And here I will focus on a single one that capture a couple of these elements that I mentioned before on some aspects of mobility and land use. Is this observable, and it's called accessibility. So the general definition of accessibility is a measure. Accessibility measures the ease of reaching valuable destinations. So it's important to measure this because people pay a premium to be in locations with greater access to the things they care about, or to save time, or to spend less on travel. Okay, this is a very generic definition, and always happens like this. If you have a very generic definition, you come out with hundreds of different ways to quantify it. And this is not different for accessibility. Matteo actually described on his work one of these aspects, in the case looking to the 15-minute city and so on. And here I will be looking to something a bit different. Still, there is two main classes of accessibility, what is called primal accessibility and dual accessibility. In the primal, what you do is what you want is you want to reach valuable destination. And here I will use a lot the term points of interest. So what we assume is, as a person in a city, he wants to reach a point of interest. And the point of interest can be a restaurant, can be a hospital, can be a park, can be whatever. And in the primal accessibility, what you do is you fix some conditions here, the distance or time, and then you calculate the number of points of interest that you can reach given that constraint. The primal is the opposite. You fix a specific point of interest that you want to reach, and then you calculate properties. What is the average distance that you take to reach that place? What is the average time? Or things like this. So you have this duality on accessibility. And I will define what is probably the most used accessibility metric called Hansen accessibility. It's a type, it falls inside the primal type. And Hansen, he defined his accessibility. It's very simple. The definition it's given by this formula. So this AI is this accessibility for this single orange person in my hexagonal map, okay, that represents a city. So the person can reach all these points of interest. Can be a restaurant, can be a grocery store, can be a ATM machine, can be a school, can be a hospital. So what he does is he counts the number of places you can reach on this OK index K is the opportunity, he calls opportunities, but he multiplies by a function. And this function is called impedance because not all points of interest have the same weight for you, because if you have a restaurant that is nearby your house, it must have a different value for you when compared to a restaurant that is, I don't know, 10 kilometers far. So you need to multiply by this function that tells you what is the price that you pay to move to reach that opportunity or that point of interest. And there's several ways to define this function. And actually there is no clear way, there's not a single method to determine what is the shape of this function. So people typically assume more exponential or a power law. They even call, when they use power law, sometimes they even call it this gravity model and so on. But a very, very simple one, and this one that will be using here, is just this square function. So basically it's 1 if the distance it's lower than a given distance. If the distance to reach that point of interest it's lower than a given threshold r, and this function is 0 if it's the distance it's larger than r. So basically what you're doing is you're tracing a radius and you only count the number of opportunities that you have inside that circle. But there is a problem with this accessibility. It's nice because it's super simple to calculate. There is a problem that what about values of each POI? So there is a important question behind when you calculate these things is, why do I move? No, so because I can plug in this equation a restaurant as a opportunity and then put a hospital as a single opportunity too, and sum 1 plus 1. But is it a hospital the same as a restaurant for a person living in the city? So we all know that this is not the case. No, each different category of points of interest must have a different value. No, so there is not a single way to compute a unique number to tell what is the accessibility of that allocation, you know. Or you calculate for each different category of POIs, and then you have like a vector of different numbers for each category, or you just ignore this and then you assume that all points of interest of different categories of restaurants, hospitals, and schools, they are all the same, and then you put all them together in an equation. And what I want to discuss today is we developed a new algorithm to determine a relative value for these different categories. So how to equate a single value of accessibility weighting different categories. And then we propose a generalization of the Hansen accessibility. So the reasoning behind is, if you remember that plot of impedance as a function of distance, we can add a new dimension that is the category. So here we have this new axis. It's not a real number, but you can add these categories in this axis. So a school, a restaurant, a mall. And then by fixing a specific distance, we can ask ourselves if it's possible to calculate an impedance function, but now in the space of the categories. So what this impedance function, or W, that here I call W, tells you is what is the relative importance when weighting these different categories to sum all they together to give you a single number. So if a school is valued 0.8, perhaps a restaurant will be valued 0.3. So you can weight these different categories in terms of importance. So we will explain very quickly how do we do this, because there's several ways to do that. Some people try to do that using mobility data. So how people visit these different places must be a proxy for the value of this place. However, this is very hard because first it involves delicate data, which is very hard to obtain for different cities and so on. And here we propose something different. We assume that this information must be inside of the spatial distribution and the correlations, the spatial correlations among these different categories. So what we do is we divide our space in hexagons. So we have like a grid in our city, and we construct a bipartite network where the first layer is each hexagon. So it's each different location where you want to calculate the accessibility. And the second layer will be the categories, so restaurants, supermarkets, ATM machines. And you connect a node from layer 1 to layer 2 if, starting from this hexagon, given this specific distance threshold R, that we can change this is a free parameter, you can access, so you can find inside the circle these categories of POIs. So the guy living here, he has a restaurant, he has also a supermarket, an ATM machine, and a school. So you have an edge on each one of between these pair of nodes. If you do this, so this is, you can, instead of, you can represent as a network, or you can represent as this matrix where you have hexagons and POI categories. And this is a matrix actually calculated for Rome. So with the load data from OpenStreetMaps, with the location of all points of interest in Rome. And this is like a matrix representation of this bipartite network. So if you guys know a bit about these theories of bipartite networks, and probably you heard about fitness and complexity. And here, this is what we were inspired. We were inspired by this approach of fitness and complexity, to come out with this generalization of accessibility. So I will explain very briefly. So this is our generalized accessibility that here we call fitness. So basically what we do is also we count the number of points of interest that you have. This is the entry of the matrix. So it's the Ij, but we have to multiply by this categorical impedance. So if a hospital, it's value 1, maybe a restaurant is value 0.5. So if I find a restaurant, for me, is only half as important as find a hospital. So, okay, this is the categorical impedance and how you compute this generalized accessibility. But in principle, how do we calculate this categorical impedance? No. So we assume a first order approximation that is, we say like, okay, if in a total random system, I expect that the value of a place must be proportional to the 1 over the number of the abundance of that category. So if I have a lot of restaurants, probably I care less if I find one. Since I have very few hospitals, one hospital must be more important than a single restaurant. So you dilute the importance if you have more. But this is like, okay, a first, like maybe a 0 order approximation. And then we go further following this recipe applied for in economics that is called the fitness and complexity. And so what we do is we say that the categorical impedance must be indeed proportional to 1 over the abundance, so the number of places of that fitness where you find that category. So if it's a very high fitness, this must contribute more for that impedance. So then you have these 2 equations that they are coupled together. So you cannot, and they are non-linear, and you cannot solve this analytically. So what we do is we solve numerically. You first you first assume that all fitness and for all impedance are equals to 1. You plug on this equation, calculate, you iterate, you calculate a new fitness and a new categorical impedance, and then you plug again on the equations and so on and so forth, up to a point where these numbers converge. When they do, you get a map something similar to that. This is a map of fitness in Rome. This is it depends on this 3 parameter that is this distance, and this is the generalized accessibility. So if we look to like a radius of 2 kilometers or 2.8 kilometers, what we have at this is the map of Rome, the one on the right. The white, just for you guys that are not from Rome, the white dot is the Vatican. So that is near the city center. So you see that the city center has very high accessibility. So in the bottom left, you have Ostia touching the sea, which is also very high fitness. And you have other clusters spread around in the city with very high fitness. We can compare this fitness and understand how does it scales with the original Hansen accessibility, now ignoring this weight. You can calculate the Hansen accessibility, assume that all points of interest are the same. They are correlated, but there is some noise in this relationship which led us to believe that the fitness it's capturing something extra. And we can show analytically that the fitness is actually basically the Hansen accessibility if you shuffle the categories of your city. So if you shuffle around the categories, where you have a hospital, can be a restaurant, so you just destroy all the spatial correlations on these categories. So you can show analytically that the fitness then becomes the original Hansen accessibility. So the fact that we have a different scaling in the real city indicates that we have this extra information that is given by these correlations. But there is, but also something that I didn't mention before is that there is a layer behind this map, no? That is the population distribution. So we can, is it to expect that, of course, that in places where you have more people living, you expect that you have more points of interest, so you have more amenities, you have more services, and then you get a higher fitness. So this would be like a naive first assumption. And indeed, we get this correlation. So if you plot fitness against the population of the place, they are correlated. But what we can do is we can calculate a z-score. So what is the deviation from the fitness, from the average behavior of this correlation, and plot this in a map. If it was like a random association between fitness and population, I would expect white noise in this map. But this is not what we get. This is Rome again. And what you see is that there is some concentration of red and blue spots. And red are places where you have a much higher fitness or generalized accessibility expected by the amount of people who lives there. Okay. And blue is the way around. So you see that the city center of Rome, you indeed find a much higher accessibility than expected by the number of people who lives there. So they have a very strong privilege regarding accessibility. You can map these categories. So each one of these dots are different points of interest, and then you can color using this categorical impedance that we calculate. And you can rank them. What are things that have a higher categorical impedance, and what are the things that have lower? So you see restaurants very, very low, bus stop have very low categorical impedance because they are very easy to find in Rome. We can show that they also follow some correlation between this categorical impedance and the number of points of interest. So the abundance of the number of points of interest on that category. And this relationship is not trivial. If it was exactly with the exponent -1, it means that you had like a random spatial distribution of points. So I don't know how much time do I have? I guess with more couple of minutes. But I'm
not much, but you can have 5 minutes if you want. So
I just okay. So the last thing that I want to show is that what we can take is you can take one of these categories. Here are hotels in Rome. So it's a very touristic city. And then you can calculate the Voronoi tessellation of the location of these hotels. And you can clearly see that the city center, you have a lot of hotels. And when you go to the periphery, you have much less. So the area is proportional to the inverse of the frequency. And then we can calculate what is the average distance for you if you are randomly located in a city to reach the closest hotel. And then you plot as a function of this categorical impedance. So the value of the category. So hotel is a single point in this plot. And then there is a correlation. So if you have very high value of categorical impedance, you have this very high distance, average distance. And we can calculate analytically what would be in a random distribution of points too. But then we see that we are we have a different scaling when we compare the real data. And this exponent is a type of measure of spatial correlation. So to finish, so I want to say that here what I want to show is that we propose a new method to estimate the weights of different points of interest categories for computing what we call the fitness of a given location. So this fitness, it captures a context-dependent nature of accessibility. And we demonstrate that fitness and categorical impedance are a pair of primal and dual accessibility. Filtering the data is an issue. It's very complicated. If you want, I can discuss this more later. And we can extend this method for other cities. So here's an example for Barcelona and for Paris. What is the landscape of accessibility for these two cities? So with this, I finish this first part of the presentation. And Not sure. Maybe we move to the second one. I don't know. How do you guys do?
I think if someone has question on this part, it's better.
Okay.
Yeah, I have a question, if I may.
Okay.
So in your slides, previously you mentioned that this fitness you defined is correlated with the what is called Hansen
accessibility
something. Yeah. So basically, in your next slide, maybe you show that if you shuffle this, yes, you get
yeah.
The slope is basically 1.
Exactly. Yes.
So does this slope mean something in this definition of fitness? For example, if we have different slope, what's the extra information you get from the fitness compared to the Hansen?
That's a good question. I don't have a final answer for this. What I can tell you is what is my feeling. Okay, I think this method is a way to measure spatial correlations too when you have multiple categories. So what we are doing is you have several species. So this is very common in ecology. So what you have is you have a spatial distribution of some species. So sometimes you have clusters, and there are several ways to measure if you have a system that is clusterized or not. No, but it's not very easy to find a way to quantify where you have different species competing for space, and this is the type of system that we have here. So each category is like a different point process in space. I think this exponent is somehow a measure of spatial correlation too. How? I don't know. Why I think this is because when I shuffle, I destroy the exponent. And shuffling, I'm not destroying the total spatial correlations because I only shuffling the categories. I'm not shuffling the position of the points, but I'm shuffling the categories and how they are associated. So I basically changing the edges of that bipartite network. So I'm destroying some type of correlation that is connected with space. So I think the exponent might be an index of this correlation, you see? There is a way to do this. We need to create a model so to generate simulated data. No, I need to start to generate other cities and see how the exponent changing depending on how I generated my data. But this will be for the future.
Okay, thank you. I have a more general question, if I may, like briefly. So basically, you define this either fitness or this Hansen accessibility to quantify if this location is somehow good in a city. Is there any let's say measure or data in a real city to show this way is correct? Or for example, if you have some data in the city, either the price of the house or whatever data, is there something you can compare with? Like if this definition of a good city is actually good?
Yeah, yes. This is also a very hard question, actually. This is harder than the other one. Because I mean, it's very hard to define what is good. Okay, there is some, you can compare with real estate data, like price of renting or things like that. And typically what you see is that Milan, and what we show is that places where you have more accessibility to the prices to buy a house are higher. Okay, the correlation is not perfect, but it's there. But does it mean that living on that place it's good? This is a hard question because then it becomes a bit of psychology, no? But there is surveys. So there is surveys, but there is all the problem with surveys. When you ask people whether they find a place nice to live or not, first it's hard to get access to this type of data. It's very expensive to produce surveys. And right now we don't have access to any of that, but it exists. It exists ways to measure these type of things, So yeah, this is something we are still fighting to compare with.
Okay, thank you.
We have
There's
time
another
for
question.
2 more questions. Yeah, maybe. John, maybe.
Yes, thank you. I'm sorry if I missed it. I had some home office interruptions to going on. So I was wondering, because you showed the map with like the fitness of places to live. Is this either accounted for and somehow with socioeconomic status, or is this something you could match with to see, is it something that structural discriminated places also have income discrimination, so that there is probably in Rome you have a strong path dependency, but in other cities where you have like more modern structures, that you have like a structural going on of like, oh, we put the hospitals where the rich people are and put the swimming pools there. I don't know if there's, especially in US cases, this might be of more interest where the cities are significantly younger.
Yeah, this is a great question. Here, we don't use any. I mean, one of my ideas by doing this work is, can we deduce all of these properties as you mentioned before, only by using the spatial distribution of the services? So my hypothesis that yes, you see, so by looking to this to the spatial distribution of the services in a city, these are a proxy for socioeconomic status on different regions, inequalities and things like this. So here we don't use as input to calculate this fitness any sort of economical or social data. We only use the spatial distribution of points of interest. Okay. One thing that we are planning to do is, okay, given that we have these maps, so we have this type with this accessibility measure map, we can then start to compare with everything you just mentioned. And we are pretty sure that they will correlate. Like we know that when we look to these maps of Rome, we know that these places that are darker are the places that are more expensive to live, and where you have more job opportunities, where you have more public services. So yeah, we are sure that we're gonna get some correlations on that, but this is something that we still have to quantify.
Okay, thank you.
Not sure. Did I answer your question?
Yeah, absolutely. And I had an input on Hanlin's point of how to measure how people are satisfied living in a place. In Germany, at least, we have one online portal where pretty much all rental offers are going. So it might be a case how often people switch places, or how often in a specific area apartments become available compared to the number of apartments. So kind of in voting by foot, that you just bypass the survey aspect and actually look into, oh, people don't want to stay in that part of the city. They get away as soon as possible.
Oh, nice. super nice. I would like to have a look on that. Maybe we can chat later, or if you want, it would be super nice if you could send me the link or something like that, so I can have a look.
Sure.
Thanks.
You can switch to the other part if you want.
Okay. Okay, I will try to move faster in the second part. So the title is Trying to Survive as a Frog in a World of Birds. So it was a bit of a joke. I'm not sure if you guys are aware about this story on birds and frogs. Have you guys ever heard about this? Anyway, so this is it's from a talk from Freeman Dyson, and he gave this talk in a I couldn't find it online. I probably this was not recorded. I'm not sure when it was gave by him, but you can find like a paper where someone transcribed this talk to a text. So, and I really recommend you guys to read. So we just mentioned that he starts by saying this, that some mathematicians are birds, others are frogs. Birds fly high in the air and survey broad vistas of mathematics out of the far horizon. They delight in the concepts that unify our thinking and bring together diverse problems for different parts of the landscape. Frogs, the opposite, live in the mud below and see only the flowers that grow nearby. They delight in the details of particular objects and they solve problems one at a time. He says that he is a frog, but he had like a lot of friends that are birds. I like this story because I think it resonates with a common dilemma that I think we suffer, at least I suffer. I guess your generation will suffer even more, I'm not sure. And for me, I think a bit more because I in Latin America, some of the things were even more complicated. So I have to twist a bit his analogy. He is talking about gods. Now, if you read the paper, he will be talking about Newton. He starts by saying like, Francis Bacon in England, he was a frog. And then in the opposite, you have René Descartes in France. He was a bird. And then he explained why he's a bird and why the other one is a frog. And so basically the birds like look to the general description to very complicated problems. They connect different fields. And while frogs solve more small problems. And he says that both of them are important. And I think that I want to twist this because first, I think this problem also, we, not gods, like human beings, no, not great mathematicians, not physicians, normal physicians, normal mathematicians also have this problem because we have to design our career. So I had this problem. I didn't know if I should just concentrate in a single topic and publish several papers on that topic, or just move from a topic to another that please me, you know. And I followed that second one, and that's why I am saying that I am a kind of a frog. And just to give you an idea, so I started working with spectroscopy and solid state when I was a student. Then I moved to AI. And then I had a paper on dunes. I think it was my first paper published regarding the dynamics of sand dunes. And then I moved to fluid dynamics. That was a completely disaster. I stayed 1 year trying to understand fluid dynamics and turbulence, and nothing worked. And then I started to work with cities. Then I moved to elections, and I have papers on all of these fields. Then when I finished my PhD, I moved to Portugal, and I started to work with soft matter, biophysics, understand the dynamics of cells. something that I had zero knowledge. And then now I moved back to cities. This is very nice. I mean, for me, it's interesting. I was working with things that I liked, and I had fun learning. I just think that today we live in a world of birds. And if you jump now, you guys can tell me, so this is a discussion if I understood well. Maybe I'm wrong, but the perspective that I got is that I was always criticized by people that evaluate my CV that I was not a specialist on anything because I kept jumping from topics to another topics to problems to another problems, you see. So I know nothing, no? I know a bit about several things, but I'm not a specialist. And this has an impact on how you obtain funding and how you get a position, you see. And I think I have the impression that it's harder and harder as our field becomes more and more competitive. And for you guys, it will be even harder. And to finish, I just think that I think it's very hard to survive as a frog, in a world of birds, but there is a big value to be a frog, no? So the value of the frog perspective is perhaps it's contribute to a richer and more multifaceted understanding of science. So we can have different perspectives because we studied different problems. And I can give you an example. So we are now finishing a paper about cities, about these spatial distributions and correlations and so on, a bit different from the one that I show you. It's with a student that just defended her master thesis. And we are using a technique to measure these spatial correlations that I actually learned when I was studying the spatial dynamics of cells. So I just translate this technique that I learned by doing something else to another problem. So you can give a fresh perspective if you know several other problems instead of just being a specialist on a single one. And I believe that the academy would be much better if we could create an environment where like frogs and birds could live together, no? I asked ChatGPT to create this image, and it's funny that he kind of create a very bit negative aspect of frogs, like everything in the frog side is a bit dark. But he tried to create an environment where the frogs and birds are living well together. But yeah, this is more or less what I wanted to say.
Does anyone want to do a comment on that? I would like to start maybe. Take the power of the chair to start the discussion. No, I mean, it would be nice, as you said, that the academia is a welcoming environment for birds and frogs, because we need both. I mean, it's related to the long-standing question of exploitation or exploration. And if, as a community, we can have both, so people that want to actually go deep in a single topic, or people that want to jump from a topic to another, and maybe the connection between the topic will be great, because so we have a collective effort toward the solution of the exploitation exploration dilemma. So just a comment. Yep, probably from the point of view of evaluating. But I also heard of people not being accepted to position because their curriculum was too specific on a topic.
Yeah,
okay. If they want to change, then it's difficult. Or if the commission value more the exploration part, so maybe it's not good to have a very specific curriculum on a topic. So this varies a lot.
Okay. Yeah. I think as we are moving, but this I cannot prove. It's just what I feel, is that as we are moving more and more to a system where everything is based on these numbers, no, based on the number of citations you have and so on. So people start to find ways to trick the system, no? So I was always recommended, and I believe this is true, if I want to have more citations, I need not only publish one single impactful paper, which is very hard, but you need to publish a series of papers on that field. So you need to be consistent. And I think by doing this, you like also create like a tendency to these extremes, no? Like people will be like more and more specialized, and yeah, like I think we are moving toward a system where it's better for you to maybe not be like super specialized, but you need to follow like a field. And I think for a PhD student, it's fine. Perhaps it's the best strategy. I don't know. I don't claim to have a solution, or actually to think that what I'm saying is indeed a problem. Maybe it's not. But yeah, maybe you guys can tell me what you feel.
I have a comment on this.
Okay.
So I think my impression is like traditionally, if you, for example, you're a researcher in physics or you're a researcher in mathematics, and the majority of people, mathematicians, physicists, might they focus on very specific area in their field. So they're expert in their small field, but they may not know the other field much. And I think if you are, for example, if you are applying a position in the Department of Physics or something like this, you may competing with these experts, and you may also evaluated by this the bird. Let's say you might be evaluated by this bird, and they may have this thought that you need to specialize in our field. So they may not like the breadth of your research that much. But I think now it's moving forward, or getting some good side is there are more and more interdisciplinary study, either the research center or some initiative, whatever. So I have the impression that people are more value the interdisciplinary study. So in this sense, it seems like people are accepting the idea that collaborating of people from very different background might be a good thing that contribute to the solution of real problems. Because although, I mean, all the time people say like different people should collaborate, but in the old world, when everyone is very specialized in their own area, my impression is the communication between different fields are quite tricky. Like they have their own language, they have their own way of doing things, etc., etc. So it might not be so easy to collaborate. But now, I guess these frogs are becoming the bridge of this bird. In such word. So first, I believe the frog are very important in like the collaboration, and I hope this way of doing research or people with this background can be valued in the future. That's my impression.
Yeah, nice. Yes. This I agree. I think I just don't know if the velocity where we are moving forward it's enough, but indeed it is. I mean, I feel this in where I am now. So this place where I am in Monteo, so the Sony CSL is a place that embrace this very interdisciplinary approach, and understand this complexity of dialogues between fields and so on, and actually promotes this. And also we are inside to a center of research called Centro Fermi, so research center of Enrico Fermi, which is also a research center dedicated to complexity, and so it embraces this dialogue between fields. I just don't know how the old departments see this, not like physics department. So if you want to go to these traditional universities, and other aspects that I feel is that I think perhaps for your generation this can be okay. I am a bit older, so what I felt is that I had very little space to make mistakes, you know. And I think that as it becomes more and more competitive to get the position, people like me that came from the global south, as you guys like to say, like from South America, I had very, very little space to make a mistake, like to waste time, like say, like, okay, I had 2 or 3 years gap. I just, after I finished my PhD, I just went to teach, and I stayed 2 or 3 years teaching and publishing very little. And I know that today I pay a price for this, you know, and I pay a bigger price than perhaps people in America or something like this, or in big centers. They also, everyone pays a price. I'm not saying that it's not hard. This life, it's very hard, no, in general. But what I hope is that that we are finding solution for this. Like we are accommodating, we are letting people a bit more free, so they can also experience different things. And I think by doing this, we can build actually a better work environment. And I also believe that they will actually foster better research.
I have a comment here as well, if I just may jump in. I don't think, because when you said like your topic was jumping a lot, my PhD was on market power. I currently work on green transformation in Germany, and we're submitting grants for inequality. So also there are a lot of jumping on. However, what has everything in common is the method and the underlying problem for which I am getting hired, which is missing data, missing and incomplete data. So I got my PhD in the US, so they played a lot there with the job market, how to phrase yourself and how to put yourself out there. So I played that card explicitly of like, well, on one hand, I'm a master of all trades. I do all the different topics. However, I'm extremely specialized on the method.
I see.
It's a little bit risky. However, if you see it from a research perspective, you should be either or, I would say. You should be either master of all trades on the method or on the topics. And the other ones should be consistent. So if you say, oh, I'm doing research on cities, you should not be fixed on your method. Because if you only run one specific method, well, this is your box, and it's not really research because topic and method is fixed, so you can only find a specific amount of solutions. However, if you're like, oh, I do research on cities, I do regression network, spatial analysis, whatever, then you're actually a researcher on cities.
Uh-huh.
But in your case, I assume you're more the researcher on the method rather than the topic from what you described. That there's a common theme on the method.
Yeah, okay, yeah, I agree. I just not sure if I could say that I had that thing very clear for me when I was doing my PhD, you know. I mean, this was a process to recognize and understand these two different paths. And also, this was not planned, was like in the flow, like, and if I could go back, I think I would do as you said, like I would focus on the method. And I'm not sure if I had very clear that back on the time. And I'm not sure if I really mastered a method too. I also touched several methods in this field, so which makes things a bit more chaotic, you know. But yeah, but I totally agree with you. I totally agree. Yes, it's a good take.
Yeah, I also totally agree in the sense that I know, for example, some researchers the starting point of their project is more like from the method. It's like I know this method very well and I want to use this method on some problems or some models. And some others may like I know a problem. I want to solve this problem no matter what method I use. I think there are two types of these are the two types of way of doing research, or two type of the style of researchers. Yeah. So for me, I think I'm. Yeah.
Sorry. Go on.
I mean, for me, I think I'm more like staying on the side of the method. I know some theory, I know some method, and I want to apply this method to a variety of problems. And my impression is some traditional physicists or traditional mathematicians, they may focus on more problems and they develop tools or develop new method to solve that problem. Well, or maybe computer science, like you have a well-defined problem to define. You work on a lot of method to solve it. So I think that's a two different way of doing things. And
exactly.
Yeah.
It's funny because if you guys read again the paper from this talk of Freeman Dyson, the end of the paper is exactly discussing this in the perspective of mathematics. So he'll be talking about the Hilbert program. No, I guess you guys heard about it. So you have the problems, the list of problems defined by Hilbert that should define the future of mathematics. And he is discussing whether this is actually good or not. And he says that he's actually mentioning another mathematics that critiques this. He says that it's better to focus on a program, not a problem. So a program is maybe a method, no? Is so to dominate, to understand the method, so we have a better general understand. But again, this is like, maybe it's a bird view. A frog likes to get dirty. This is the problem. A frog likes to jump around and look a problem here with a single method, and he is happy when he solves the problem. And then he moves to something else, you know? And but yeah, maybe just to finish with this, again, another provocation.
Great. So we have a very nice discussion actually, and the topic is far from being covered. But fine.
Sorry, I'm not understand you well.
Can you hear me now?
Yeah, now it's better. Okay, sorry.
So I think we are out of time now, and we have to finish the discussion, but it was very interesting and actually very important. So thank you, Hygor, again.
Thank you, guys.
It was a pleasure to have you. And
thank you.
We will see you all in 2 weeks. We will have another seminar. Okay. Thank you very much.
Thank you. Bye-bye.
Bye-bye.
Thank you.